So photoelectric effect is nothing but we have observed one phenomena. What we have observed, that when we send light on certain surface, we see that some electrons are coming out, okay, and there is some current flowing. That is what is called photoelectric effect. Releasing electrons when they are exposed to light of appropriate frequency is called photoelectric effect, okay, and the electrons which are emitted during this process are called photoelectrons. See, for example, here I'll reduce the intensity and I'll reduce the wave. Yes. See, now there is no light falling on this metal. Yes. So there is no light falling on this metal. Okay. But let us. Okay. There is no light falling on this metal. Okay. This is your basic observation. What we did, we tried to increase the intensity. Based on your normal intensity is nothing but the power. Okay. The light is dim. Slowly we are increasing the light intensity. Okay. See this power we are increasing. Okay, 1.2, 2.5, 3, 4, like that we are increasing the power. Okay, can you say me, increasing the power, will the electron come out of the like the metal rod? Yes, increasing this power will be useful for getting the electron out of this metal.
Yes, sir. When suitable frequency fall on it, electrons emitted from it.
Yes, but I am talking about intensity. Will intensity affect this?
Yeah, sir, I think so.
Maybe, we don't know. Let's check it out. Okay, so see, I'm increasing the intensity. I have increased the intensity very much. There is lot of light, like full torch I have on, but there is no electron coming out. Okay, this is what was our experimental observation. What was that? That increasing the intensity did not affect the emission of electrons. Okay, if even though we are increasing the intensity, that is not affecting the emission of electron. Okay, now we'll see another phenomena. We will decrease the intensity, okay, a moderate one, and we will decrease the lambda value. Okay, basically decreasing the lambda, will it increase the energy or decrease the energy, right? So
Yes,
I'm
sir.
increasing the energy, I'm decreasing the lambda and increasing the frequency, I'm increasing the energy. Slowly I'm increasing the energy. Okay, at one point of time I can see there are some electron coming out, right? Now let me increase some voltage also. Can you see there are some electron coming out, right? Yes. 570 we are getting. 580, can we write 580? Yes, 580 also we are getting. But for 590 we are not getting, right? So for 580 we are getting the electrons, but for 590 we are not getting the electrons, right? So 2.14 for certain value of decreasing the lambda or increasing the frequency made the emission of electron, right? That at certain value of frequency or certain value of lambda, we saw that there is an emission of electron. Okay. Yes. Now we'll talk about two different things. Now I'll increase the intensity. Basically, previously we increased the intensity, but there was no electron emission. Now I have increased the energy and there is an electron emission. Now I'll increase the intensity also at the same time. Okay. Can you see that there are more number of electrons coming out,
Yes, sir.
right? So increasing the intensity helped in the more number of electron emission. और कितने photon बाहर आए are two different things. So the photon coming out is one thing and number of photons coming out is another thing. Okay, that if I decrease the energy, and even though I am increasing the intensity or decreasing the intensity, it does not affect. Okay, but to emit even one electron, I need one photon. Okay, with the minimum energy. Did you got this point?
Yes, sir.
Yes. Okay. Nice. Now we'll talk about threshold frequency. What is energy? Energy of energy of photon. This is H. Sorry. Energy of photon. How much is that? H F. Right. As we increase F, energy increases. So the minimum value of F, that is F naught, for which the electron gets emitted, okay, that is called as threshold frequency. Okay, that is called as threshold frequency. It is the minimum frequency of incident light or radiation that will produce a photoelectric effect, that is ejection of photoelectrons from the metal surface, is known as threshold frequency for the metal. It is constant for specific metal but may be different for different metals. We'll talk about this in the next slide. So let's say the frequency of incident photon, and Rth is the threshold frequency. For all the frequency which is less than Rth, there will be no ejection of photoelectron. Okay, if it is equal to Rth, are just ejected. Okay, and if it is greater than Rth, then the photoelectron will come out with some kinetic energy. This term we'll learn later. First, let us talk about threshold wavelength also. Okay, so what is frequency? 1 by wavelength, right? Frequency is what? C by lambda. So they are inversely proportional. So for a particular f naught threshold frequency, we'll have a lambda naught also. Threshold wavelength. Threshold wavelength. Okay. So this wavelength is called as threshold wavelength. Mm, what is the threshold wavelength for this metal? This is cesium, Cs. Okay. It was 585, 580, right? For 580, we observe that some of the electrons are coming, right? Let's check if the threshold, if we get some for 590. We are not getting for anything for 590. For 580, we are getting the electrons. So 580 is the threshold wavelength of this metal, right? Did you understand this point? Threshold wavelength and threshold frequency. Yes.
Yes, sir.
The next one is work function. Okay, so it is the minimum energy required. Here you see for 580, how much is the energy? 2.14 electron, right? Electron volt, right? And for cesium it is 2.12. The work function of cesium is 2.12. So this is the minimum amount of energy. Cesium 2.12 electron volt is required work function. 2.12 electron volt, it is the minimum energy required, okay, to eject electron. Now this minimum is called as work function. For different metal, that work function is different. For sodium it is 2.27, okay. For beryllium it is 2.51. For francium it is 4.36. Let's take francium. As I took francium, there is no electron emitting for the same wavelength, right? Because the work function has increased. Now again I have to decrease the lambda. Okay, how much I have to decrease? I have to decrease it till around 4, 4.36. So 4.36, 300. I'll make it 290. I can make it 280. 280 is 4.443, right? Approximately 4.43. So if you take this one, 4.43 is, you can take 4.47. So yes, for the minimum energy required to eject the electron is called the work function, right? That is the work function. For energy which is less than the work function, no photoelectric effect will take place. For energy which is equal to photoelectron effect, the electron take place, the kinetic energy is zero. We'll come to kinetic energy in the later part. Okay, for greater than that, it will eject the electron. That thing is clear. Yes.